Welcome back everybody to Chapter 2 of Math 1342. We will be starting with Chapter 2, Section 1, or as we normally notate it, Section 2.1. And in this section, we're going to be talking about organizing data. Later in the chapter, we're going to be getting into graphs, but for just this section, we're going to be just talking about organizing the data using a frequency distribution. So the first thing that we're going to do is we're going to learn or talk about what is raw data or data. This is data that is just collected by the researcher. Oftentimes it's not even organized, it's just listed out as they gathered it. So in this case, we have the raw data for the 50th wealthiest people in the world's ages. And we're going to use what's known as a frequency distribution to organize the data. So this is our main goal for Section 2.1, is learn how to do this frequency distribution. So the first thing we're going to do with a frequency distribution is we're going to make what are known as classes. So the classes in a frequency distribution are groupings. So what we're going to do is, instead of listing out all 50 ages separately, we're going to define these classes and mark down how many are in each class. So I'm going to go a little bit above and beyond what it's asking us to do right now, just because I think it makes more sense to kind of understand this right now. So they've decided to do 3, 4, 5, 6, 7, 8 classes. Now that's completely up to whoever's making the frequency table or whatever the problem asks you to do. So if we have 8 classes, what we need to do is we need to look at the data and we need to find the largest and the smallest data value. So let's see, I see a 92. Is there anything bigger than a 92? I don't think so. So I think 92 is our largest data value, or our highest age. And then we're going to look for the smallest. So it looks like the smallest might be right next to it. I think it might be that 27. So let's look through here. Yes. So it looks like the largest is a 92 and the smallest is a 27. So what we're going to do is we're going to divide from 27 to 92 into those number of classes that we want. Now remember, our goal this time, just because this is what they've done, is to do 8 classes. So if we take 92 minus 27, we'll get the distance between that highest and lowest point. So you would calculate 92 minus 27, and then you would take that number and you would divide it by the 8 classes. So in this case, we have 65 between those two numbers. And so we need a span of 65 for our 8 classes. And so we're going to take 65 and we're going to divide it by 8. And 65 divided by 8 gets us just over 8, because 64 divided by 8, of course, would be 8. So it actually comes out to be 8.125. And because it's just over 8, that means we have to do class widths of 9. Because if we do a class width of just 8, we won't get all the way to 92 with our classes. So that 8.125 means we're going to do a width of 9 for the classes. Okay, so that gets us, our starting value is 27, and we're going to have 27. I'm just going to recreate what they did, but I'm going to show what they did. So here's the classes. So we're going to start with 27 and we want a width of 9, which means we want 9 values that will go into there. So if you count 27, 28, 29, 30, 31, 32, 33, 34, 35, That's 9 numbers. Whoops, hold on one second. Okay, now if you take 35 minus 27, you're going to get 8, but that's because you're counting how much it is between 27 and 35. But if you count all the numbers, 27, 28, 29, 30, 31, 32, 33, 34, 35, that's 9 numbers. So we have 9 numbers, or ages in this case, that would go into the class of 27 to 35. Now we're going to do the same thing for the next one. And this is where you can actually see the 9 better. So 27 to 36 is 9. And then 35 plus 9 would be 44. Again, if we count this class, 36, 37, 38, 39, 40, 41, 42, 43, 44, that's 9 numbers. And from here to here is 9, from here to here is 9. So the beginning of this class to the end of this class is 9 numbers, but if you go from 27 to 36, that's 9 away. Okay, and so we stopped at 44, so we're going to pick up at 45. A lot of times what I'll do is I'll do all of the first ones at this point because I'm just adding 9. So 45, 54, 63, remember from here to here is 9 away. So 54, 63, 72, that's 6 classes so far. And then we're going to go 81, and then our last class is going to start with 90. Okay, and then I can do the same thing with the bottom, or with the lower class bound. And so the lower class, we've got 44, so this one's going to go to 53. And you can kind of check if you're right, because this one should end, and then this one should pick up. So this one ends at 53, this one picks up at 54. Okay, and then 62, this one starts at 63, and then 50, not 50, hold on, 71, and then that ends at 71, this one picks up at 72, this one ended at 80, I'm sorry, this one started at 80, so this one would end at 80, 81 to 89, and then our last one would be 90 to 89 plus 9 would be 100. I'm sorry, not 100, 98. Sorry, I was thinking about something else, not paying attention to my addition. Okay, so here's our classes, and then we're going to go through here, and I'm not going to do this whole thing because it would take quite a while with 50 data values, but I'm going to show you where they got these data values. So what you would do if you were doing this by hand is you would go through here and you'd start to mark down where each of these are. So you can either go down the columns or across the rows. I tend to like to go down the columns, but it doesn't really matter. So I'm going to start with 45 and I'm going to make a mark. So 45, and then I'm going to make a mark for the 92. So I've so far marked this one and this one down. 27, 54, 61 would be in that same category. 88 would be from 81 to 89. So I've gotten to here. I'm just marking this down so you can tell where I am. You don't necessarily have to mark them off as you go. 81, 55, 81, 55, and then 49 and 46 would both be in that class. Okay, so that's what they would do for all 50 of those. You know, you'd pick back up here, 46, 51, 66, 44, 68, 45. I wanted to get the one where we could mark. And typically with the, so we've gotten all the way to here. Typically when you get to 5, you mark through it and then you start over so you can just kind of count your tallies easier. And so then in our table that we have below, our frequency distribution table, these frequencies are the sum of these tallies after you get done marking them all down. So now let's look at what they had. So they had, after they did all that work, that in the first class, there was only one. It's only one person that had ages between 27 and 35. 36 to 44, there were 3 people. 45 to 53, 9 people, and so on. And so you can kind of easily tell like where the most common. So you can tell pretty clearly that the ages 54 to 71, that had 25 people in it. So half of the people fell between 54 and 71. And you can kind of see that grouping. So it's, you know, kind of the younger ages is not as common. It's a little bit more common when we get up in the mid 40s. And then these are pretty common. And then it kind of tapers off. Well, it goes down and it goes up and then down, but not as much in these age groups as there was in these 3 age groups. So it's just a way to kind of gather that data together without having all 50 values listed out. So we have our classes, and those are like our other books I've seen call those bins. So it's like where we're going to drop our number. So for instance, up here, you know, our 45, we dropped into the bin of 45 to 53. So we made a mark and dropped that number into that bin or into that class. And when you get all done, of course, you should be able to add up these frequencies and get the total of the number of data values you had. So if we had done this and then you go to add them up and you don't get 50, you'd have to unfortunately go back and kind of recount, retally, and figure out where you went wrong because you should have 50. Okay, so now it's going to kind of discuss the classes. So we've kind of discussed a little bit of this already. The class limits give a range of numbers. So all the ages between 27 and 35 belong in the class 27 to 35. And then, of course, all the ages 36 to 44 belong in this class, and so on. And so this is what they call a grouped frequency distribution, because the individual data values are collected into those groups of classes. And then you just get the frequency. So if you had just gotten this information, you wouldn't, if you hadn't had the raw data, if we didn't have the raw data, we wouldn't know exactly how many people were 55. We would just know that there were 15 people from 54 to 62 if we weren't given the raw data. So, you know, the frequency distribution is great to kind of see those patterns and kind of collect data up. But if it's all that you're given, you lose some of the data because you don't know all the information. And then it says if the range of a numerical data is small, you do just use its own class. And that's called an ungrouped frequency distribution. So, you know, if your numbers only go, say you're taking, you know, how many students scored a certain number on a quiz, and everybody on the quiz scored between 6 to 10, you wouldn't do a group frequency distribution for that. You wouldn't do a group for, oh, let's do 6 and 7 and 8 and 9 and 10 and above. I mean, that would just be kind of silly. So if you have a very small range of numerical data, you don't really need to do a group distribution, a grouped frequency distribution like we did here. But here we had all the way from 27 to, what was it, 92. And so it made sense, since we had a such a wide range of numbers, 27 to 92, since we had 65 values between 27 and 92, or a distance of 65, then it made sense to kind of group those numbers together instead of keeping them all separate. And then the other thing we can do is, if the data is only nominal or ordinal level, we can do what's called a categorical frequency distribution. And that just lists, instead of class limits, it just lists out whatever category it is. So the next example that we have is of that. So in this case, it says you've got 40 people that were asked what they drink for breakfast. Do they drink water? Do they drink milk? Do they drink juice? Do they drink coffee? Or do they drink tea? And so we could take this data and do the same thing, except we don't have grouped classes. We just have the names of the different drinks: water, milk, juice, coffee, tea. And again, if you were doing this on your own, you would probably write down the different categories and then go through and start to mark down. So W gets 1. Oops, hold on, that didn't look very good. Okay, so W gets 1. I'm going to go down the column. Coffee gets 1. water, milk, water. And you would do that, there's your first column, and then you would do that for your other columns. And so we're going to kind of cheat a little bit and just go what they have here. So they've already got it completed for us. So they've gone through and they've tallied that up, and this is what they've gotten for the group frequency distribution. I'm sorry, the categorical frequency distribution. Again, the grouped frequency is when you group the numbers into classes. We're just doing a categorical frequency distribution because these are just categories, not groups of numbers. Okay, so now they've added some extra columns here, so let's not worry about those quite yet. Let me look at or mark off, this is what we've done, or they've done so far, or what we've talked about, is classes and frequencies. So water, there were 14 people who said they drank water, milk, 8 people, juice, 6 people, coffee, 9, tea, 3, for a total of 40 people. Now, they've also done the work to include a relative frequency column in this graph. Now, where do those relative frequencies come from? Well, go back to what this word means. So relative, when you're thinking about in everyday English, what does relative mean? Well, relative means in comparison to. So if somebody were to ask you, is it hot today? You would say, in comparison to what? If it's January and it's 65 out, it might be hot today compared to what it was last week. If it's the summer and it's 65, you may say, no, it's not hot today because last week it was in the 90s. So relative is in comparison to. So if we think about what is a relative frequency is in comparison to the whole. So in this case, the relative frequencies of each of these frequencies, 14, 8, 6, 9, 3, would be in comparison to the total. I'm going to change that. Let's say instead of saying total, or instead of saying whole, let's say total. Okay, so in comparison to the total. So in the case of this, we have it written down here, but we'll do a couple more. Instead of saying 14, the researcher could say there were 14 people that drank water out of the 40. And if you do that on your calculator, 14 divided by 40 comes out to be 0.35. So 0.35 is the decimal answer, the decimal equivalent to 14/40ths. And so that would be the relative frequency. So you could say the relative frequency, or you could say the percent. I know they have the percent listed out here, and they even have it down here in the description. But in all honesty, we don't put the percent when we're talking about just like a statistics class type of table. Now, they might put that in a newspaper article or within a research study or something like that. But what we're going to do mostly is this relative frequency. So we're not going to convert it from 0.35 to 35%. We're just going to leave it 0.35. So 0.35 of the data, or 35% of the data, was water. And sometimes the researcher would rather present it in that manner. Like, they don't want it to be just, oh, well, there were 14. And then you have to think, oh, well, that was out of 40. How much, how does that compare? They just want to do the comparison. So they just want to say, well, that was 0.35 of the data, or 35% of the data. If we do the next one, 8 out of 40, that comes out to be 0.2 when you divide that. So again, on your calculator, just do 8 divided by 40, and you would get 0.2, and then 0.2 is the same as 20%. You always shift it 2 decimal spots, or a lot of people think of it as multiplying by 100. Then if we did 6 out of 40, scooch down a little bit. So if we did 6 out of 40, that comes out to be 6 divided by 40 is 0.15. And so 0.15 of the data, or 15% of the data, was people answering that they drank juice. So we're converting it to, instead of being out of 40, we're converting it to be, what would it be out of 100? Or what would it be out of if we think of the total as one whole? Now, if you add either the percentages up, the percentages should add up to 100%. Or again, we're going to be doing this more often. If you add these up, it should get 1, because this is the parts of the whole. So if we add those all up, then you should get a total of 1. So again, you know you've done it correctly or you should, pretty good guess that you've done it correctly if it adds up to 1. All right, so they're giving us another group frequency distribution. And this says it's a group frequency distribution of the diastolic blood pressure levels for 50 randomly selected adults. So let's just kind of analyze this. The class limits describe which values belong in each class. So this is what we've done so far. We've done class limits. You can kind of include different things in your frequency distributions. You can include just the class limits and the frequencies. You could do the class limits, frequencies, and relative frequencies. In this case, they've done the class limits, which we've done in every one. They've also included the boundaries. And that will be helpful when we do our graphs. So the class boundaries, remember from chapter 1, we learned how to do boundaries. So boundaries is just going a little bit below and a little bit above so that we have, we don't have a gap in between our classes. So with the class limits, it jumps from 64 to 65. But with the class boundaries, you close that gap. So you go down a half and up a half. So the 58, instead of calling it 58, we call it 57.5 to 64.5. It really doesn't add anything to what would go into that class because we don't have any halves with our ages. They're all whole numbers. So saying we're going from 57.5 to 64.5, we still have the numbers 58, 59, 60, up to 64. It doesn't add any new numbers in there. Same thing here. We're just going to go down a half and up a half. And these are what's called the class boundaries. We will use those when we graph in section 2.2. So the class boundaries separate the classes so that there are no gaps in the frequency distribution. So if you were to happen to have a 64.2, you would now know where it goes. Okay. Also, the lower boundary is 1/2 less than the lower limit, and the upper boundary is 1/2 greater than the upper limit. So again, down a half from 58 gets you 57.5, up a half from 64 gives you 64.5. And this will make a lot more sense when we do the graphing. Okay, so just a couple questions. What's the difference between the class limit of 68 to 64 and the class boundaries? As we mentioned, there's no gap. So there's no gap between the classes with the boundaries. And then it said, suppose you measured someone's blood pressure. Again, we don't normally, I said ages up here. We're doing blood pressure. But anyway, suppose you measured someone's blood pressure and the actual value was 64.3. Where would you put that? Well, if we look up here, 64.3 would be in this class. 64.3 would be in the, we could say it's 58 to 64 for the class, or if we did it with the boundaries, it would be 57.5 to 64.5. And so just like we did in chapter 1, we think about where would 64.3 go if it was rounded to the nearest whole number. 64.3 would round to 64, so it would be in this category. Or if you have the boundaries in there, you can see it even more clearly because you can see, well, 64.3 is between 57.5 and 64.5. So let's look at the class widths and the midpoints. We've talked about the widths actually quite a little bit. So hopefully the class widths won't feel too new. But the class width is found in two ways. You can either subtract the lower limit of one class from the lower limit of the next class, or you can do the upper minus the upper. So if we think back or go back to this one we just did, we hadn't really talked about the width on this one because it was already kind of completed for us. But what's the width here? Well, we've got 58 to 64. We could count and we could say that's 58, 59, 60, 61, 62, 63, and 64. They're all in that class of 58 to 64. So the class width is 1, 2, 3, 4, 5, 6, 7. We're going to do this like 3 different ways. So the width is 7. Or, that kind of gets tedious counting the numbers. So what if we just take, instead of counting 58, 59, 60, 61, 62, 63, 64, what if we just said, let's go from the lower one here to the lower one here and see how far that is. Well, 65 minus 58 is 7. Or we could go from the upper to the upper. I'll mark it here. Let's mark it with a different color. So we could go from the upper of this one to the lower of this one. I'm sorry, the upper of this one to the upper of the previous one. So 71 minus 64 is also 7. And then you can do a similar method with the boundaries. You can go lower to lower, and these will all get you the same number. So you can do 64.5 minus 57.5, and that will give you 7. Or you could go 61 or 71.5 minus 64.5, and that would also get you 7. So I would recommend you just stick with one way, whichever way makes the most sense to you to determine a class width. I would say I typically go with the lower limit of the class to the next lower limit of the class. But they all work. So if one of these others makes more sense, if you like going from the upper to the upper and subtracting those, that's fine. If you'd rather count them, 58, 59, 58, 59, 60, 61, 62, 63, 64, and count how many are in the first class and then use that, that works too. So whatever makes sense to you. And you might start one way and then later be like, oh, that doesn't make as much sense. I actually like this way better. But once you kind of find what works best for you, I'd just stick with it and do it the same way every time. Okay. So let's go down here. So it says, these are just what we just said, but with the, they just wrote out what we just did. So you can do the class boundaries, you can do the limits. And then the other thing is, how do we get a midpoint? So the midpoint of a class is literally just the halfway number between the class limits or the class boundaries. They'll give you the same answer. So it's the average of the lower and the higher. So the lower boundary and the upper boundary divided by 2, or the lower limit and the upper limit divided by 2. We'll do one example. And in this case, let's do something besides the first one. We've done the first one a lot. So let's do let's do this class right here. Okay, so if we wanted to find the midpoint of this class, again, I could use these numbers or I could use the boundaries, but I'm just going to use these numbers. Okay, so we're going to do 79 plus 85, and then we're going to divide by 2, and that will give us the average of 79 and 85, or what number is midway, or the midpoint between those two numbers. So add those two numbers, you get 164, and then when we divide that by 2, you get 82. And so the midpoint between these two numbers is 82. I kind of wanted to write it somewhere. Okay, so the midpoint for this is 82. And you could do that for any of these classes. Let's do one more. So if we did 93 plus 99, we get 192, and then divide that by 2, you get 96. So the midpoint between 93 and 99 is 96. And another way to find the width of the classes is you can subtract these two also. So 96 minus 82 would also give us 7. And I just realized that they've made a mistake on this table. They should not have left out the class limit between 85 and 93. These should all match up. There shouldn't be any gaps. So they should not have left out, because 82 minus 96, of course, is not 7. They should not have left out the category. Let me write it off to the side. So they should have done 78, 9 to 85. And then they should have done 86 to 92. And then they should have done 93 to 99. And if 86 to 92, it looks like what happened is there wasn't any data values between 86 and 92. They should have just left it in here and made it 0. So there should be a 0 in between here. And there should be a class here. Let me see if I can get this to erase and look halfway decent. So let's get rid of this. Okay, so what they should have done is they should have had another row here with a 0 in it. And over here they should have had another class limit that was from 86 to 92. That's kind of disappointing. But it's a good way to actually point out that class should be left in there. You should go from the beginning to the end, but if there's any classes in between that don't have any data values, you don't just throw them out. You leave them in there, and then you write that the frequency was 0. And again, that way you would have the distance between them 7. So let's write what we had here. So the midpoint, remember we found for the midpoint for 79 to 85 was 82. And then we had the midpoint for 93 to 99 was 96. We should have had a midpoint for 86 to 92 that was at 89. So 82 to 89 is 7, and then 89 to 96 is 7. So the distance, the class width, should be those distances between the midpoints. Okay, so let's go down. Learn how to do the midpoints. And we have some just general rules for frequency distributions. So in these, there are some things that are hard and fast rules, and some are just kind of niceties. So there should be between 5 and 20 classes. So we'll say if it's a nicety, we'll put a plus sign by it. So between 5 and 20 classes, that's kind of a nicety. It's not a hard and fast rule. You could have 4, you could have 25. But the idea is if you get too many classes, it just gets too big and too hard to really interpret. And so if you don't need 5 classes, a lot of times they'll say, well, just leave it out. Kind of like we were talking about with the quiz scores. If you don't need at least 5 classes, just leave the data values out as non-grouped data in your table. And then it is preferable for the class widths to be odd. And again, here it says preferable. The reason for that is because then the class midpoints have the same place as the data value. So you notice when we were doing those up there, we got like 96 as a midpoint. If you don't make the class widths odd, that would have come out as like a half instead of just coming out to be like 90. What were our values? We had, I've forgotten already. So we had our midpoints of 82, 89, 96. If this was not a width of 7, say it was a width of 6, then these midpoints would have come out with halves. It would have been like 82.5 or 81.5. And so if you keep them odd, it makes the midpoints a little nicer. But it's not, again, a mandatory. So we'll mark that as a nicety. So it's a nicety or preferable to have the class widths be odd. This, however, put a star if it's a must. Okay. The classes must be mutually exclusive. And that means you can't overlap the classes. So you can't have, for instance, in our example, you could not have had a class that went from 68 to 64 and then have the next class start at 63. You can't have them overlap. That makes it so that when you have a number, you don't know where it goes. So if we had 58 to 64 and then our next class was 63 to 69, where would you put the 64? Would it go in the first class or would it go in the next class? So we can't have these classes overlapping each other. And so that means that they have to be mutually exclusive. Think about what mutually exclusive means in everyday language. It means most of the time mutually exclusive we talk about with a relationship, it means you're not dating someone else. You're only limited to one person. And that's kind of what it means here too. It means that each number should know exactly where it goes. There should be no confusion as to whether where a number falls. The class that it goes into, there should be only one choice for it. Okay, and then continuous. See, it even says it right here, even though they didn't do it up above. The classes must be continuous, and even if there are no values in class, it must be included in the frequency distribution to prevent gaps. Unless it's the first or the last class. If it's the first or the last class, you can just leave it off. It wouldn't need to be there. But if it's in the middle, like that other one was, they even say right here, so I'm not sure if somebody edited that after it was made thinking they were doing the right thing, but that class there should not be a gap between those classes. Again, even if there's no data values in the class, you have to include it and then put it as 0. And then the classes must be exhaustive, which means, and that's a must, meaning every data value you have has to have someplace to go. So you can't have it stop short like on that other one with the ages. We couldn't have stopped at 90 and had no place for the person who was 92 to go. And that one was kind of interesting. Let's go back up and look at that one. So remember, our highest value for this one was for the people's ages. I didn't feel like it was back this far, but it's back quite a bit. So remember, we went all the way up to 98 with this class limit, but our oldest person was 92. But we had to include this class, or the person who was 91 and the person who was 92 would have had no place to go. So even though we had to include numbers that beyond 92 that we didn't really need, we have to have it or we wouldn't have had any place for those last 2 oldest people to go. Okay. So 5 to 20 classes preferable, class widths odd preferable, but they must be mutually exclusive, they must be continuous, they must be exhaustive. And then the classes must be equal in width. Again, that's a must. So the first 2 are niceties. These last four are musts. They have to be like that. And then we just have a procedural table here. Some people that are real kind of word-oriented, linguistic-oriented, they really like to see it written out. And so this is what we did with that first frequency distribution table with the ages. We figured out the highest and lowest. We figured out the range. We decided, or they had already decided for us, that there was going to be 8 classes. Then you find the width by dividing, select the smallest point, which is usually the lowest value, and then go through and write down your upper limits and your lower limits and your boundaries. And then we went through and tallied it. That's where you mark it. How many are of each type? Where does each data value fall? And then you find the numerical frequencies. And then if you want to, you can do the cumulative frequencies. We haven't done cumulative frequencies yet. So we did relative frequencies and frequencies. So if desired, you can also do cumulative frequencies. And so we're going to do that now. So this is the one that we already did, 92 and 27. Again, we kind of cheated and worked ahead on this. We already did that before. So all we need to cover, our very last thing, is just what is a cumulative frequency distribution. So if you look at the cumulative frequency for a class, and add its frequency to the sum of the frequencies of all the lower class. So what we're going to do is, instead of saying what the frequency is, we're going to say how many are there or below. So this one, for instance, is one value is 37 or less. Okay, so you think of your limit here. So one of our values is 37 or less. Now, if we go up to this next one and we think of the 48, how many values are 48 or less? And remember, our value in this case is age. So how many ages or how many values were 48 or less? Well, we had the 1 that was between 27 and 37, and then we had 10 more that were from 38 to 48. So together, 1 and 10, we get 11. So 11 values are 48 or less. Then we do the same thing. This one right here, this number that we want to write here, is how many values are, what do we have here? 59 or less. So we look at this category, which has 13 in it, but then we also look at the 10 and the 11. So 13 plus 10, that's 23, plus one more, that's 24. You also can just take what we've already added and just add it and go from there. So 11 plus 13 gives you 24. But if we wanted to go back to the raw frequencies, that would be the 13, the 10, and the 1 that added up to 24. And then 24 plus 12 gets us 36. Again, if we went over here, that'd be the 12 plus the 13 plus the 10 plus the 11. And that means 36 values are 70 or less. And we keep doing that till we get to the end. And this number here, this cumulative frequency at the end, we're saying 50 of the ages are 92 or less. And so then we have the total. Oh, and I do want to point out, I kind of skipped over it because we'd already done it with the other one. But for this one, they had done the classes differently. So these numbers come out differently because they did it with only 6 classes. And we did it with the 8 classes. But it was the same, it's the same information. So it came out a little different because they only did 6 classes. Don't want to confuse anybody. Okay, but these should total up to 50 because altogether there were 50 people in the survey, and so, or 50 people in the raw data, and so we should total up that 50 are 92 or less. Okay, so notice that each cumulative frequency is the sum of the class frequency in the previous one, or it's the sum of all the prior frequencies. that frequency plus all the prior ones. So 7 plus 7 plus 12 plus 13 plus 10 plus 1 gets us the 50. 7 plus 12 plus 13 plus 10 plus 1 would give us the 43. Okay, that's all we have for this section, and we will pick up with the next video with how do we take these frequency distributions, whether it's frequency, relative frequency, or cumulative frequency, and make those into a graph, into graphs. Oh, I did want to mention, we didn't talk about the word cumulative. So if you're trying to remember what does cumulative frequency, think of the word in our everyday language, accumulate. So accumulate means to collect things up, gather things up. And so that's what a cumulative frequency is, gathering the frequencies from that point backwards. All right, I'll see you in the next section, and you should be ready to do your section 2-1 homework now if you would like to get started on it.